Thank you guys, everyone, for coming. I know it's kind of tough with COVID, but I really appreciate it. So Baltimore said that we're okay. Masks are required, I'm sorry, except for the speaker up here, except when you're eating or drinking. So that was one of the conditions. But thanks for coming out. I'm not quite sure how many more in person we'll do. I'm going to see how it goes for the next couple months. So tonight I'm really honored to have Dr. Stephen Penn talking about using quantum computers to estimate lottery revenue. So I've known Dr. Penn for a while, and I think you spoke before, but I've done so many of these I forget, and I'm old now. But and he's a really great speaker and very passionate about what he works on, so I think it'll be a great talk. So before we get started, I would like to thank our sponsors. So they've been sponsoring even through COVID, which was awesome. So Daring Technologies has been a sponsor for several years. They do a lot of defense contracting, smaller size business, but do some interesting work. If you're interested in learning more, you just reach out to me. Clearance is another defense contractor. They do a lot of cloud computing, data science, data analytics. They're actually trying to work with me on a conference, which there's going to be an announcement about in a second. So if you're interested to learn about them, you can contact me. Arius is my company. We're giving out free books in the back, free notebooks. I think you took one. They're really awesome notebooks. My favorite thing about having a company is buying swag. So if you like them. And then Microsoft is now sponsoring us. So it's a pretty big partnership there, and hopefully they'll get a little more involved with the conference, providing maybe some credit for Azure and things like that. So I'm working on the schedule for next month. I've had a couple changes, so I'm trying to finalize that. It might be an O'Reilly speaker, or it might be someone from Envale. I'm trying to get them. I'm not sure if anyone knows about Envale. They do specific cryptography. It's kind of interesting. And then Loyola, we're going to have some speakers from the Loyola Data Science program, and then some blockchain conversations. And then going into the next 2020, I have all those books. If you're interested in being involved, always reach out. Just come talk to me or send me an email. Love to have help. Can you click the next? Okay. So I was trying to do an online conference for September, but we're going to postpone. I just couldn't get the speakers. We were getting people interested, but the speakers were challenging. So we're going to give it another shot in spring and maybe do it in person or virtual. So if you're interested, please sign up. I don't know really what's going to happen with the cost or the timing yet, but I'm trying to gauge interest at this point. Okay, so we have two speakers actually. So Amidi is, she's in the back right here. So she's going to talk in 1 second. So she's part of the Data Science Corps. So what happened is earlier in the year, there's a group called the BNIA. If you guys are familiar with it, they do a lot of data-related things in the Baltimore area. And they do this program called the Data Science Corps, where students work with them and get assigned to different programs to work on projects over the summer. So DataWorks submitted, and Amidi was assigned to us. So what she's been working on is looking at the meetup data to see if there's any interesting things about the group or other groups. So she's going to speak in 1 second. I'm going to introduce Dr. Penn, and then we're going to switch again. And then Dr. Penn earned his Doctor of Management from the University of Maryland, University College. His dissertation focused on data-driven decision-making, and he's worked in IT for almost 30 years, and he's currently at Harrisburg University. So this is quite a drive for you probably, so thank you. But I've heard him speak, and he does an amazing job. It's really like a passion. So with that, I'm going to get your laptop hooked up, and I would suggest everybody turn to a neighbor, introduce yourself, divide time for a second. We'll go from there. So let's put your...
I have a very good A little bit because it's much smaller.
I think we've met before. What's your name again? Nasir. Rory. I said I'm Rory. Rory. Yeah. Good to see you, man. All right. I'm Rory. I'm Nathan. Nathan. Nice to meet you. Yeah. Flip it up there. Aaron? Aaron or Eric? Aaron. Yeah. Can you give us a first? I'm not. Okay. You just came from far away. Is that right?
No, I actually.
Okay. We're going to start up again. So,
No, it's okay. He's actually doing it.
Mimi's with the University of Baltimore, and she's going to be talking about her work she's been doing with the meetup. So, with you.
Yeah. So hi everyone. I'm really excited to be here. So as Jason said, I'm an accounting student. I work with Binia. I was an intern with Binia, where I had to use data science tools to find useful information, for an organization here in Baltimore. So here are my findings. So I worked for a few weeks this summer, and here are my findings. So DataWorks MD has 2,243 members, as some of you might know, as of yesterday. And then majority of the members are IT professionals, so I had to look, I had to go through all the bio. Not everyone wrote a bio, but for some who wrote a bio, here are some of the professions, engineers, professors, statisticians, and yeah, that's everything here. Product manager, small business owners, we have a lot of entrepreneurs, grad students, machine learning experts, and biomedical engineers. So they are interested in everything related to those things. So okay. So women members. So I noticed while going through the whole list that there are many women members of DataWorks MD. So yeah, so I used Meetup API. I worked on DataWorks MD Meetup page mostly. So I'll use Meetup API, and for some reason it only returned 800 members. I think it's because those are the ones who are more interactive with the page. So it only returned 800 members. So out of those 800 members, 177 are women. 177 plus are women. So I based that based on so the female names, the English female, because I saw some name I wasn't sure if it was male or female. So the English female first name. So yeah, so 177 women, so it's about 22% of the group are women. And I also saw that other meetup groups, data-related meetup groups, they have mutual members with DataWorks MD, and those ones here. So women who go. So many of the members from DataWorks MD are also members of those groups here. So women who code, women data scientists in Baltimore, Baltimore Women Tech, women who code in Richmond, etc. Washington DC, women in big data. So you can see that women who code, we have 33 members, mutual members with them. So where do DataWorks MD members live? So most are Baltimoreans. Yeah, so 547 members live in Baltimore, but we also have some on the West Coast. In California, you can see the red bar over there, 15 members over there. We have some in Canada, 10 in Ontario, and there are some in Ottawa as well. So yeah, and then some are in New York and in the south of the country. So yeah, I was saying that over here is, so members who are in remote places in New York and, in California and Ontario were pretty active during the COVID lockdown, due to like the virtual meetings. So many of them, were pretty attended. So here it is again. 741 members in the US, Canada, England, France, in Baltimore. Here in Baltimore, 216 members. Washington DC, we have many members in Colombia as well. So this was important for events, like where to hold events. So we wanted to know where they live, like mostly in Baltimore, Columbia. So maybe, yeah, events can be held in Columbia as well. Okay, so when did members join DataWorks MD? So DataWorks MD was started in 2018, like in June 2018. So there were 85 members for those 6 months in 2018. In 2019, 134 members, additional members joined the group. In 2020, 272 members. In 2020 alone, joined the group. 2021, 309 members. So we are in August and we have over 309 members who already joined the group. So I was saying that if we continue, if that trend continue, it could be over 5 members for 2021 alone. So I think it's growing, the membership is growing pretty fast, which is a really good thing. And during the COVID-19 membership, the growth has been really high. 3 times more than the previous years. So yeah. So yeah, this is about the same information. For this month alone in August, there were 20 plus members joined. So it's been growing every day. Like when I when I get on the page, there's always members, more members. So. So active members, I saw that, again, when I went through the whole list, the 800 members, I saw that about 15 of them are loyal members. So since 2018, they've been around. They've been attending meetings, they're still attending meetings. And they check the page frequently. The virtual setting attracted different crowd, as I said, people from other states, from remote states. And so members check the via Meetup API, I can see that members check the page about every 2 weeks. So that's where it is that they're really interacting, they're really engaged. Creation date, not joining date. So I also ran an API query and I saw that 222 members created the page, a Meetup page, and that same day they also joined DataWorks MD. So I feel like there are a lot of interpretations to that. But I thought it was just an interesting data to know that the same day they had the Meetup page also joined DataWorks MD. So I was thinking that DataWorks MD has a high visibility on Meetup. That could be one of the reasons, recommendations wise marketing. And then second, maybe the members heard about DataWorks MD somewhere else. And then they decided to join the group to be more, to be part of it, to be more involved in the group. Okay, so other data related data groups in the DMV. So there are many of them who cater to the data community. And what about same content I've said? So yeah, some of them are Maryland AI, statistical seminars, data science, so they're really popular. And so those groups offer topics. When I went through the topics or the events and things like that, it's about the same topic as DataWorks MD. Around healthcare, coding skills, artificial intelligence. And then so over there, I could not find the creation date of those groups, but I could see the first event date. So I was thinking it's pretty close. DataWorks MD, I started in July 2018. I had the first event in July 2018, and then now they are at 2,300 members. And then we can see code for Baltimore, statistical seminars. So those events were created about the same year, and you can see that the membership is about the same. Actually, DataWorks MD membership is higher compared to groups that were created that same year. So I thought that was interesting. AI in healthcare has 2,000 members, but they were created in 2016, so 2 years prior. So yeah, just to show that DataWorks MD is doing pretty good in membership. So popular topics on Meetup. So I looked at other DataWorks groups, and then here are some of the events they had that had a very big attendance. So I thought maybe those were topics that people were really interested in. So here, as you can see, I'm not gonna read it, but yeah. So for example, the first one, 277 attendees, and then yeah, using graph and HKs. So yeah, so that's what it says there, but okay, so that's the attendance that showed on Meetup API, but as you may know, it can be that number, but people want to show, more people can show up, or, you know, there will be a lower attendance. So that was just on Meetup API page. So events, DataWorks MD had its first 145 plus attendees. It was at the beginning of the pandemic, so it was around, November 2019. So it was at UMBC, robotics and machine learning. So yeah, so that was the first 145 plus attendees, according to what I saw on Meetup API, and since then we had many more 145 plus attendees, or more people that were more interested in being at the events. So yeah, here the second most popular event. So events centered around, I noticed that events centered around machine learning, data visualization, data science, entrepreneurship seem to attract a lot of people. So yeah. And I just want to add that DataWorks MD would like to know there are some topics that people are really interested in. They would like to know to really cater the members. So in-person events versus virtual events. So here's the graph when I entered the data. Here's what I found. And I found that it wasn't that much different. You know, I want to say virtual event leadership is slightly more people or slightly bigger attendance, but I feel like it's just about the same. And as I pointed out earlier, it's just a different crowd. So different people attended this event or signed up to attend this event. But it's about, no big difference. So yeah, that's pretty much it. Thank you so much, and yeah, I really enjoyed working with this organization because I really like, I would say, the professionalism, the quality of the content, the consistency of DataWorks MD. So I thought it was great. I really enjoyed looking into the data and everything. So that's what I got. Thank you.
Why do you do that? I just wanted to say a couple things. So if you're interested in learning more about the program, Carlos is actually in the back. I didn't mean to put you on the spot. So Carlos worked with me a lot on it, and as he's doing it, I'll tell you, it was kind of interesting, right? So they had to use the Meetup API, and she was using like Jupyter Notebooks and Python. But we quickly found out that Meetup wants you to pay to get certain access. So I already pay to have the group, but they want you to pay more to be a Meetup Pro just to get certain API access. And then even once you get that, they kind of do restrict certain access. So like some of the ideas we had was to try to get all the groups that every member was part of and then kind of put that all together in some data structure to see what the top was. They will allow you to do that. There's a lot of back and forth. Carlos, I looked at it a lot. And then even like I think I had to add certain accesses to allow you to get things. So they definitely want you to pay. I thought that was kind of interesting. That was it. So she did a great job. If you're interested in the program, you can reach out to me or I say Carlos or talk to her. But I think you're looking for submissions now. Yeah. And there's been other projects that we're working. So if you go to their webpage, they'll have a lot of other students that we're working with other organizations. It's up to you. You got this.
Got you up. I think so.
Could you go?
Okay.
So can everybody hear my voice? If I can check. Okay. I will try to keep the volume up, but if I'm not, just okay. Okay. So quantum, it's new. There's talk about it. Is it here yet? Not really, right? Not really. Why did I get interested in quantum? So, a lot of people are spending a lot of money these days on quantum and building quantum computers, right? Building, because they're not kind of here yet. And that's where the money is. But in the 80s, they started talking about how to build them. In the 90s, they proved that algorithms could actually, new algorithms could actually solve different problems. Right? So people got really excited in the 90s. In the 2000s, they started actually building really, really tiny ones. And in the last few years, they actually got some up and running. The one that I'm going to talk about tonight is, it's called an adiabatic quantum computer. It's one of the simpler ones. Okay, so I'm going to talk about the simpler ones for a couple of reasons, right? Tonight's talk has two purposes. One is how do you get started in learning about quantum, right? So I'm going to tell you how I did it, right? And I'm not saying I'm an expert, but I've been trying to learn, right? Again, and then the second thing is kind of goes back to my own kind of research, my own interest, and that is the business side of things. Like, I love IT, but I like also studying how people use IT. That's really what I'm interested in. It's not I'm not a computer scientist. I'm a business management researcher. So what I really want to interested in is how do you build a quantum workforce? Like, okay, so they're building quantum computers, right? Okay, good. Who's going to code? Who's going to be the business analyst who says, okay, let's take a complex problem and translate it to a quantum computer? And then who's going to train those individuals? And then who's going to be the salespeople that go out and try to, right? I mean, how do you do that? How do you do that? Okay. I don't think that's well defined. So that's kind of my interest in quantum. So from the business side, like how do you build a quantum workflow? And I also kind of believe that in order to answer that question, you kind of need to know what a quantum computer is. Okay. All right. So we're going to say how do you access a quantum computer? We'll do this real quick because I've got like 30 slides, a lot of information. Somebody asked, is this going to be like a workshop? Can I bring my computer? We got too many slides to go through it now. So we're going to make this kind of go. And there's one slide in particular that I kind of want to emphasize out of the 30. So we'll get to it. We'll get to it. So what I'm hoping at the end of this is that you have like in your head, like a game plan. Like, oh, okay, I can log on to that website, I can do this, I can do that. And then the second thing is, okay, let's say you have a job, you're a computer programmer, you want to kind of pick up some quantum skills. Okay, so what do you do? How do you go to your boss and say, I want to kind of spend some time on this, right? Well, your boss is going to say, why? Right, like, you don't do quantum, so why, right? So here's the deal. Think of an optimization problem. Okay? An optimization problem could be anything. It could be like, what do we sell the most of to get the most profit? Right? It could be like, let's say you run an IT department and you issue laptops to our employees. Okay, how many spare laptops do you need? Right? A spare laptop is money you're going to spend, but it's just going to sit there until someone needs it. So you don't want to spend a lot of money on spare laptops. So what's the minimum number of spare laptops you need for a workforce of 250 employees? That's an optimization problem. Right? I want everybody to have a laptop all the time, but I don't want to spend too much money on it. Okay, optimization. All right, so let's find an optimization problem. How many help desk technicians do I need because I have X number of problems to, right, optimization. We'll find an optimization problem. We'll do some Python programming, and boom, you're in quantum business. All right? Okay, so let's go. All right. So I picked the lottery. I'm not guessing the random lottery numbers. I'm not doing it. I mean, that would be the coolest part ever. I'm not. Okay. So what am I doing? let's say you work for Pennsylvania Lottery. I picked Pennsylvania because it has 67 counties, and that's the reason why. Your job at the PA Lottery is to sell lottery tickets and scratch-offs and bring in revenue. It's a voluntary tax. So your job is to collect revenue for the state of Pennsylvania. Okay, great. Okay, if it's a voluntary tax, who buys the lottery tickets? Well, you kind of help people with the money, not the people without them. You don't want to sell lottery tickets to the low income, because then you're taxing low income, and then you're spending that money on education, which is usually the middle class. So you're taking it from the okay. So let's try to sell as many lottery tickets as we can. That's a maximization, and yet sell as few to low income as possible. Right? Exactly. Right? How do you sell tickets to everybody, but you don't want this to become a, I think they call it a regressive tax. But anyway, you don't want it to become that. Okay. All right. So that's what we're going to try to solve on our quantity. Here, why did I pick that? Because to me, that's like a whole dynamic give and take, and it's a real business problem. So if we can move that to the QPU, the quantum processing unit, we would show to our boss, hey, I can do quantum programming, I just want to do more, right? And kind of do it at a baby step kind of thing, kind of take one step into quantum at a time. If you really want to get into quantum, you need to know linear algebra, which is matrix algebra. Okay? I did matrix algebra in my undergrad, and math is undergrad. I was like, that was years ago, right? Nobody's paid me to do linear algebra since. Okay, so I got to teach myself anyway algebra again, right? Okay, I'm confident I can learn it. I learned it once, but I need to learn it again. Okay, well, tonight we're not going to do that. We're going to do college algebra. We do need to learn college algebra. Okay, so we want to maximize revenue, minimize time. Okay, I picked PA because the PA lottery has 67 counties. I downloaded some data from PA Lottery. Went to their website, downloaded some data. I know how many tickets they sell over the last several years. I know their advertising budget over the last several years. Right? Okay. I know it by county. Okay. Their budget is full, give or take, depending on the year. It kind of increases as they sell more tickets. They get more advertising budget. It's 44 million. So they spend 44 million in advertising. They don't break that number down for me. And I didn't talk to anybody from PA Lottery. I just downloaded from the website. So I'm not exactly sure if is it radio commercials, is it billboards, I don't know. Let's say it's all billboards. Okay, we're simplifying. Okay, we're simplifying. Okay. And it's by county. Okay, I'm simplifying. Okay, all right. But that's what I did for this problem. I simplified. So I want to spend the 44 million on the counties that typically buy a lot of tickets, but don't have a lot of poor people. Okay, does that make sense? Philadelphia, a lot of poor people. A lot of people, so I probably do want to advertise there, but, right? Okay. So you get my problem, right? Where are we going to advertise to generate sales, to bring in tax revenue for the state, but not make it tax heavy on certain individuals that don't need to pay that much tax to begin with, right? Okay. All right. We want to find D-Waves, the company. They do everything in minimization. Okay? So we want to maximize revenue, right? We want to maximize revenue. Okay. But D-Wave forces us to do minimization. We're forced to find this on the D-Wave quantum computer. What do? We just flip it. Right? And now it's minimization. Okay. All right. I'm going to go over minimization, optimization in Excel real quick. Just so that we know that people have been doing optimization for a long time. Why do we want to do it on a quantum computer? Right? So I'll make that argument a few slides down. So I'll show you what's on Excel, and then we'll go over to quantum. Okay. when we go over to quantum, it'll be kind of cool because we'll start building some of the skills, real basic skills in an hour. What can we do in an hour? But that'll be a launching pad for going to quantum much later, after this. Okay, here's how I solved the problem in Excel. Okay. I downloaded the yellow brownish data, so I know the population for each county, and I know the percent of population that's considered low income, right? And I'm not, everybody can buy lottery tickets, right? We just don't want to tax. We don't want to create a tax burden on certain things. Okay, the purple is how much I'm willing to spend in advertising in each county. Minimum 0, maximum X. I kind of said, I wish I had the data to download from PA Lottery, but didn't, so I made it up. Okay? So I'm giving this information to Excel. I'm giving this information to Excel. These are my constraints in optimization. I'm not willing to spend all 44 million in a rural country county. Right? I kind of have my limits. Let's put some limits on this. Okay. So those, I came up with the purple altogether. The green is what Excel comes up with. Okay? So I'm telling Excel, I want to maximize this number. This is my budget. I want to spend every dollar here and no more. And then this is my constraint on how much I'm willing to take in from low income. It's a hard constraint. Okay? Does that make sense? I'm saying I'm willing to take in this much money, but no more from low income. Middle income, upper income, tax, yeah. Right? Okay. Right, okay, those are okay. But we want to generate income for the state.
Just a quick question. Is it purple columns?
Yes.
The advertising budget maximum, do you set that?
I said that.
Okay.
Yes, I said that, which is arbitrary.
Oh, so it's not as if you base on the average income of that county and say, oh, this number is higher for that county?
I kind of did it. I did a little regression, and then kind of gave it some wiggle room.
It looks like it roughly correlates with population.
Exactly. That's how I did it. I used population as a regression and tried to do it. Yeah. That's how I did it. I wish I had more data to get a little more sophisticated, but yeah. for the point, it's getting the job done.
And the actual budget is, the actual income, the actual ad budget is what each county is willing to spend? Or
How much PA Lottery is willing to spend in billboard advertising in that county?
yeah, so that you have to be on
I have lottery sales tickets by county, but I have an advertising budget for the whole state. Yes! If I had a number to somebody who worked at PA Lottery, I would call them up and say, give me your data. Okay, I don't know. So, okay. Right, okay. But it is good because the more we understand about this, when we get the quantum, we'll be like, oh, I know exactly what we're doing. Was that another question? Was that? It's good. It's good. Okay. Again, we want to spend all of this, but we want to meet our advertising budget, right? If the state gives us $44 million to spend, we're going to spend all of it in advertising, not less, not more. Okay. So basically, right, Excel tells us where to spend this $44 million in the different counties, and maybe we'll bring in that much revenue for the state. Okay. So that's how we would solve it in Excel. We want, here's what I think is cool about quantum. We're going to build an algebraic equation, and we're going to dump everything in this algebraic equation. Okay? The budget, tickets per person, that creates a different way to approach the problem, and the management person in me says that's going to create a different discussion about the problem, right? Which kind of fascinates me. How do you talk about the problem? Okay, so instead of putting in hard constraints like per county, like you go from 0 to X for that county. You can go to 0 to Y for that county, which is arbitrary. What if we kind of did a trade-off? Like, we didn't say 500 million of revenue from low income and just said, that's a hard constraint. What if we said, if we can make more money and go over the 500 million? Over.
Are you talking about tolerances now?
Yeah, right. A little more, yeah, give it some wiggle room, right? Give it a tolerance, give it a, so can we do that, right? Okay. So hard constraints, soft constraints, it depends how you phrase it. This is how the qubits, okay? A qubit is a variable that sits on the QPU, and it's a 0 or 1. Traditional computers, zeros and ones, right? Right? Okay. The difference between a traditional computer and a quantum computer is that in the quantum computer, before you get your zeros and ones, those qubits are everything. Schrodinger's cat, right? Is the cat alive or dead? And the answer is yes, right? Okay, right? Okay. The reason why quantum computers eventually we're going to deal with linear algebra and matrix algebra tonight, but the reason why it wants to is because you can influence the probabilities of those zeros and ones. So before it becomes a 0 and 1, okay, it's in this superposition, which means it's both. How do you represent that? You represent that by probabilities. 50% chance 1, 50% chance 0. 90%. And now you're talking having multiple numbers to represent one qubit, which means you're kind of creating matrices, which means you need to get into matrix algebra. Okay. We're going to hold off on that right now. We're still going to go on zeros and ones. We're still going to think about zeros and ones. Because as we pull data off the QPU, that's what they're going to become. As soon as we measure the qubits, the qubits come back and say, I'm a 0. Right? But then before you measure it, the qubit's not necessarily mean. So there is some differences between traditional and quantum computers. When we get the zeros and ones off the QPU, we call that sampling. It's just zeros and ones. Okay. But we have to think in zeros and ones. And that's good because it's going to set us up for advanced quantum computers later on. What do I mean by zeros and ones?
Can the algorithm that predicts whether it's a 0 or 1 be trained?
Absolutely. You do that by multiplying matrices together. So you put it in one state, you multiply it. You can entangle qubits. You can say whatever that qubit is, this one has to be the same, right? Right, exactly. But you do it through math, right? So I kind of had to go back in time to my undergrad days and kind of teach myself math before I taught myself quantum, right? But it's all math. So it's on that. If you went to college algebra, you can handle linear algebra. It's just one of them. It's just one. Okay, so qubits have probabilities, measuring forces and qubits from ones, everything's fine there. 1A, Python functions as constraints. You can write a Python function that says, my budget is 44 million. The problem with doing, I did it that way, that was the first thing I ever wrote. When I wrote it, it came back, everything was fine. Basically, I said, my budget's 44 million, give me a bunch of qubits that represent a $44 million budget. Everything's good, right? I kept that up and increased the number of qubits. The problem is that, what's bad for me? You're going from the QPU to the traditional computer to run the Python, back to the QPU, back to the slow. You don't want that. You just avoid that. You want all of your constraints in that algebra form. It's going to move to the QPU, the sampling's going to happen, it's going to happen. But you can't do it that way. It's just, so 1A and 3A kind of go together. That was my first step. Just get something running, right? But you eventually want to go to 1B and 3B. That's what we're talking about tonight. 1B and more. All right. log on to D-Wave, create an account, easy, easy, easy. Once you get an account, you get 1 second of life of the QPU. I've never come close to using a fourth of a second. I mean, you're boom, and then you're back over, right? You hit the QPU and you're back over. The QPU like has to be maintained at a really cool temperature, so they don't like to run it very much. But so 1 second doesn't sound like very much, but really most of your code's going to run on your traditional computers or your laptop, right? Windows open, and that's that. I mean, you can run 1,000. But the QPU will that. You won't run out of second. So create an account, very easy, very. Okay. Here's the algebra. Everybody got it? Ready to move on to the next slide? All right, I'm just kidding. We're gonna convert this to a simpler version, and I'll explain what it is. But it uses the word Hamiltonian. Hamiltonian is just another word for energy state. And so we're trying to do a minimization. So we're trying to get a minimum energy state on the CPU sample. That's all. No expense. Let's move on. All right, this is simple. Okay, I still don't like this. It's simpler. It's the same equation. It's simpler. I still don't like it because Q is what we're going to give the computer. We're going to give the computer coefficients. Okay? X are the qubits. Why is it Q the qubit and X the coefficient? I don't know. It seems backwards to me. We determine Q. The QPU determines the X. Okay, fine. I think it's backwards, but fine. Okay. But again, I never talked to anybody from D-Wave. D-Wave's never talked to me. D-Wave's never asked me my opinion of their formula. So it's fine. Everything's good. Okay, so what we want to do is set up the Q's for this algebraic equation. Okay? Coefficients. Those coefficients are the things that's going to influence the energy state of the QPU so that we can sample zeros and ones. Okay? All we want is zeros and ones, but we want to influence which zeros and ones come back. So that we can take those zeros and ones, translate them back to the logical problem, and say, where are we going to spend our money? Okay. All right, so we have to develop the Q's. We have to develop the coefficients. All right. The way, we're not developing them yet. I'm just saying we're going to tell them. This is the way we're going to tell them. Okay. We take all of we have 67 counties. I'm going to represent each county by 1 qubit. If that qubit is on, we spend $1 million per county. This is me defining the business problem. Okay. This isn't D-Wave, this isn't quantum, this is me defining the business problem. If the qubit comes back 0 for that particular county, we don't spend money. We don't spend any money. That is way, way simplified. With more time, I can make it more elaborate. With more data from the lottery, I can make it more elaborate, a little more sophisticated. But for tonight, we've got 44 million. We're going to spend it in 44 chunks, and we're going to spend $1 million in a county. So which 44 counties did that represent? Okay. All right. So now I have a problem. Right? I mean, if I'm going to define the business problem that way, now my problem is get it to the D-Wave. Get that business problem to D-Wave. This could be Dauphin County. This could be Philadelphia County. This could be all the counties in PA. They also go across the top. So it creates a matrix of 67 counties by 67 rows by 67 columns. When it's here, this means Dauphin County by Dauphin County. That's just the same qubit, right? When it's here, what happens when we spend money in Dauphin County and Philadelphia County? Okay, so we have to shift our logic. Okay, now don't forget about the PA lottery for just a second. Forget about PA lottery for just a second. Let's say I've got a card deck of 52 cards, and I'm going to deal myself 5 cards. Which cards do I get? If I was doing this with traditional programming with Python, I would create 5 variables, and this variable would be the first card, that would be the second card, that would be the third one. This variable could take a number between 1 and 52. Once I've decided that one, I would pull that card out of the deck, and then this one could be 1 to 51. Okay, right? That's how I would program it. Dealing cards from the deck for a 5 card game. Okay. Qubits can only be zeros and ones. And then quantum computing is like traditional computing back in the 60s, like 50s, 60s, right? When assembler was like the language, right? We're dealing in zeros and ones. I have to rethink that problem of dealing myself 5 cards out of 52. Think of 52 qubits. If the card is in the deck, the qubit that represents that card is 0. If I pull that card off the deck with my hand, that qubit is now 1. This is my hand. It's like flip it, okay? And that's because quantum computers are just not as evolved as traditional computers. Traditional computers are 0 and 1s, right? Qubits are the same way. They're just not as evolved. Okay. All right. So I have to create a matrix in Python, hand that matrix off the D-Wave. D-Wave takes it, puts it on top of the QPU. I get my zeros and ones back. I know where to spin my money. All right. If you have a laptop running Python, you're qualified to be a quantum programmer. Great. Yes. Because it's the same 67 counties down as across, you really only need to give it the main diagonal and the upper right corner. Because the upper right corner is sort of the lower right corner is exactly the same. This is the structure of the Python program. We're going to import some statements at the top saying, hey, D-Wave, we're going to access you, right? Import statements in Python. We're going to build our combo matrix. We're going to sample qubits, and then we're going to print a solution. Easy, right? I even typed it. It's so easy. Exclamation. Right? It's just import. It's just import statements. Okay. This is me reading in the data from CSV file. Populations. This is, right? I mean, this is reading in CSV file. Still easy. More code. And you can kind of see how I code. I mean, I'm trying to make it as simple, right? I write Python code once every couple of months. So I have to be able to go back to my Python code and I like it. Okay. All right. Here's the slide that's the kicker. Here's the one that I want to spend some time on. We have a budget of 44 million, right? We have 67 qubits representing the 67 counties of Pennsylvania. So far, so good. Okay. If a particular qubit gets turned on to 1, we're going to spend $1 million in that county. I don't want 45 counties receiving $1 million. If 45 counties go to 1, I'm spending $45 million, not 44. If I spend $43 million, 43 counties turn on to 1. I haven't spent my whole budget. That's not going to be it. So exactly 44 counties to turn on. Meaning become ones. The other 23 counties is 0. I have to put that in an algebraic equation. So far, so good? Okay. So I say x plus 1, x sub 1 plus x sub 2, right? The 67 counties have to sum to 44. I start with that. I want to make it a minimization problem, so I move the 44 to the left-hand side of the equation. Right? This is just college algebra. We're not doing linear algebra yet. So now it's starting to look like a minimization problem, but it's minimization. What's the minimum value I can get out of x plus x plus x plus x plus minus 44? It's all zeros minus 44. So quantum computer's going to come back and say, don't spend any money. If you don't spend any money, you're not going to get any revenue, but you're not going to tax the limit too, right? Okay. I got to fix that. I got to fix it so that when you spend exactly 44, that's the lowest value, right? Everything else creates positive numbers greater than 0. Okay, so Okay, have you ever read a math book and you go, and you read the top of the paragraph and it says, it can easily be seen that this formula converts this?
Clearly.
That's what I do on this slide. That's me, that's what, I get to read the math also. Okay, you square it. Isn't that simple? Okay, wait, why do you square it? Because if you square it, right, if you only spend 43 million out of the 44, and there's 43 some, that's 43 counties turn on, there's 43 ones, sum of 43, minus 44 becomes negative 1. Square negative 1. 1, which is negative 0. So now, so when the 44 counties turn on, 44 minus 44 is 0, square 0. It's 0. So now that if you see it in a curve, and now you take the bottom half of the curve and flip it up, so now the 0 is the bottom. That's another graphical way of saying it. So we just square it. That's why math comes into play. So math kind of, if you're going to deep weighted programming, they used to call it algebra, and that'll be the launchpad for linear algebra, which is the launchpad programming. So D-Wave is actually pretty cool in the sense that it's kind of like a stepping stone. Okay, so now we've got our main diagonal, negative 43, negative 43, negative 43, and now we've got our upper right corner, 2, 2, 2, 2, 2. Is that kind of big? That's the key. That's the baseline.
So each one of those terms represents a cube, a matrix.
Yep. Okay. Yep. And as we sample, we get our zeros and ones, right? So our coefficients influence which zeros and ones come back. Yeah. And that's what we want. We don't want to write a Python definite function, def function in Python, because then we're going back and forth to forming the original result. We want to do this Cuba formula, and it's ones that Hamiltonian, that integers thing, and then that gives us our 44 ones back. But we still haven't solved everything yet. So I'm loading up my. You have to name your matrix cubic underscore boxes. If you do that, people knows what you're talking about. Okay. You don't get to name your matrix. It's kind of that. So I'm building the upper right of all the twos. Right? That just came from the previous slide when we squared it. Here's the negative 43. Okay. Here's where it's a little bit of an art. I want the 44 million spent, no more, no less. But I'm dumping everything in the same column, the same column down to the formula, right? So now I got to move the populations of every county in that same formula. So I kind of have to weigh the coefficients a little bit, like which coefficient do I think is more important? Spending on budget or non-taxing. Or this is where the trade-off, this is where the conversation kind of takes place. Like, okay, so is the 44 million really a hard number that can't go low, can't go below? Well, if we went back to the states and then maybe they would give us, if we had a good case, okay, fine, right? This is where that conversation, this is what fascinates me about quantum computing is that maybe from a management perspective, it is different. It is different. Okay. So you can see where I'm using the population of the counties to kind of influence the biases. So it is possible the quantum computer comes back and says, you really need to spend 43 million to get what you want. That's still a ton of money you're bringing in. But so it's different than the Excel problem, right? The Excel problem said, cannot go above this. Can't go above that. Those are hard constraints. This is wishy-washy. Tolerances. Okay. So the point of this slide is we can dump as much as we want into that couple of those coefficients. We can keep modifying them, keep modifying them, keep modifying them as much as we want. So I came up with the idea, if this is all just billboard advertising, and it's people driving on the freeway, and they see billboards. How many people live in Gettysburg and drive to Harrisburg? They can see a billboard in one county and then buy the ticket, which influenced them, and buy the ticket in the other county. So advertising in one county may influence sales in the adjacent counties because of commuters. Maybe not during COVID when everybody's working from home, but maybe, I don't know. So let's talk about it. Let's have a discussion, bring in some experts, right? And figure out the formula. In lottery, we could add points. Like, we could sell this much through gas stations, this much through grocery stores, this much through restaurants, Keno through bars, lottery, what else? The jackpot size influences lottery sales. All these things influence lottery sales. We just keep adding to the coefficients, keep adding to the coefficients, just keep adding to the coefficients. It's all just algebra. Here's where at the bottom, right? Print the solution, right? Just grab your zeros and ones, and then print out the counts. I've coded this in Jupyter, right? And just kind of ran, that's the reason why I've got it in sections. Just copy and paste and then ran. I kind of, because if I want to add in another loop to modify my coefficients, I just kind of create a box, modify coefficients. Right. And then I'm printing the county names. Get which county they can put it up. I'm using one qubit for $1 million to expand one county. I could create more qubits, grab more stuff. D-Wave has thousands of qubits that you can use, where most, the adiabatic computer, quantum computers is limited, and they're mostly doing minimization problems. You can't do fancier things with it, but you can get more qubits. So you go D-Wave, you cannot. Okay. All right. So we just interpret the results, right? Our job is to translate those zeros and ones back into the real world population and kind of figure out spend advertising here, maximize revenue for the state, minimize how many dollars you get from a certain group of people, everything is good. All right. We can compare the results. The Microsoft Excel kind of gave us some more detailed information, right? Because Excel was written back in the 80s, I think. It's a more sophisticated tool. Quantum's not as sophisticated yet, but as we get better at programming, as a quantum workforce, we start doing things that are far more advanced. And Shor's algorithm or Broder's algorithm, some of these quantum algorithms, they're saying quantum computers break blockchain. It depends on the algorithm. But now some of those algorithms are not only depending on linear algebra, but also abstract algebra. They get really advanced. But that's the potential of quantum computers. Okay, so we kind of said what's a real simple physics problem to solve an optimization problem, and they're everywhere. And then can we solve it on a D-Wave machine? Yes, just using lots of programs. That was the objective. Just get our, take a dip and just get our feet wet. We could do all kinds of things. We kind of talked about this already. Things we could add, enhance. We would have more data, access to experts. Check the size, we talked about that. Motion optimization, we talked about that. We dynamic conversation and how we view the problem. That's what the best is. Okay. At this point, we know what D-Wave offers, zeros and ones, right? They don't offer us the ability to manipulate the exact probabilities of those qubits. You know how I said probability 50-50 chance and 90-10 chance? D-Wave is simpler in that we influence it by setting up a college algebra equation and then moving that to the PPU and do the zeros and ones back. On more advanced quantum computers, okay, that they're building now but only have like tens of qubits, you actually do the linear algebra, you actually say, oh, it's a 5% chance, 25% chance. And then the income, the entanglement, you actually go through that math. So D-Wave kind of simplifies things, but it is an entry point. So if you want to go further in quantum computers, or like quantum programming, there's Qiskit, there's a programming language from IBM, there's Ticket, there's all this stuff. There are some good books out there that kind of take you through what is quantum mechanics, and then what is linear algebra, and then how you bring those two together to manipulate a quantum computer. D-Wave has its own documentation, right? Anybody play Pokemon? Okay. Okay. There was a gentleman from D-Wave who made a video that said he wanted to pick the best 5 Pokemon in his card game, right? And he explains what Pokemon is. I watched it and I thought that is the coolest thing. Like, I don't know Pokemon, but that is the coolest thing. I mean, it was pretty cool. He does the same thing, like how he uses zeros and ones to represent Pokemon in the game, and then how he invite the way he right. D-Wave's got lots of great documentation. I've submitted questions on the forums, got an answer right now. Very good. So D-Wave, and I'm not advocating D-Wave. There's companies that forming all the time. But they do offer a simple model so that you could do some quantum programming, show some success, show some skills, and then maybe 2, 3 years, 4 years, when these promised quantum computers come out, you're ready for joining the quantum workforce. That's it. So I had 2 goals, right? One goal was so that you could walk away tonight with like, this is my next couple of steps. This is what I want to do, right? And the second thing what you walk away with is the ability to pick a optimization problem at work and then bring those two together. Okay. So that was my. I hope I did that. I'm getting something. Okay. And again. Quantum is growing. It's not here yet. It's a good time to jump in. There's a lot out there. And you may think 1 second is not much time. It's a ton of time. Yes?
Yeah, you said it's not here yet. So could you just describe how it's going to be when it is here yet? Just give a broader example.
Yeah. Okay, so that's what interests me. So I teach at Harrisburg University, which is up in Pittsburgh. Harrisburg, anybody heard of Harrisburg University? Yeah. It's a small university. We're not in IT. Okay? We're not. We don't have huge curriculum. So UMD, Maryland, MIT, big schools are spending a ton of money on different kinds of quantum computers. Some use photons, some use electrons, some use anything that behaves in a quantum mechanical way. Okay. They're getting to where they have 40, 50 qubits to where you can do some advanced programming, like truly manipulate these things. They need to get it to the thousands. And the reason why is that they keep that quantum computer so cold, right? So that there's little influence from the outside world to influence. You want your programming influence to keep you, not anything else. It's an energy state. So you want any energy getting in. You want it at like 0.0000000 Kelvin, right? Okay. Anything that gets in is going to mess up those qubits. So they need to have enough qubits to solve your business problem, plus enough qubits left over to actually check and see if they got it right. Error correction on that, and we're not there yet. Thousands of qubits. D-Wave offers thousands of qubits, but you're pretty much limited to optimization. Okay. So now the companies that are out there are Getty, IBM, and some other. They're promising that these quantum computers will be out in 3 to 4 years. Or that's. I'm not a quantum expert. Right? I mean, the people who are doing this are physicists and engineers. I'm a manager. But from what I understand, 3 to 4 years is when these quantum computers are starting. Now they are, D-Wave has its business model is we want to create clients first and then create the quantum computer. They do have an adiabatic quantum computer, but it's very limited. And that's the reason why I'm saying I'm not advocating D-Wave. I'm just saying if you want to learn, it's practice on your machine. It's free. So you may want to learn Qiskit and these other programming languages that are geared towards these high-level machines. They're not. So you can practice Qiskit now. You're just not going to have a great quantum computer work. Or you can work with D-Wave and have plenty of qubits that will be able to solve crack that password. It's got to be utilization. So 3 to 4 years, the computers should be out and solving complex business problems. And then that's when the idea is that quantum workforce came about. Yeah, that.
So is it safe to assume that we don't even know what it's capable of yet in terms of business solutions and whatnot?
So that's what. So back in the 80s, they were saying the world is actually quantum. The world is actually quantum. What you and I see as human beings is Newtonian, but like Newton's physics, right? But the world is actually quantum. It's like Max Planck's physics. Therefore, the computers that we use should be quantum computers because those are the problems that we actually solve. Those are the problems because that's how it works. There are so many problems. Gene therapy, right? Chromosomes, right? Are just the amino acids like form a chain, but not really. It falls back on themselves. They're 3-dimensional. So the chromosomes are actually jam-packed. So it's not just a sequencing issue. It's a 3-dimensional visualization.
With 4 different types of structures.
It's
4
like,
different levels of
oh
structure.
my God, right? And then the data tables, the human table, it's just all these variables to describe chromosomes, right? Okay, that's like really cool for a quantum computer. I mean, quantum computers like that's the that's what it is. To do that though, you have to understand genes and biology, right? Quantum programming, which is matrix algebra, right? So building a quantum workforce is not going to be easy. It's just not. So that I think that's the fascinating part. They are working on algorithms now. They are practicing with these limited computers now, and they are tackling these issues. So like one of D-Wave's bragging stories, right, is a supermarket chain up in Canada because shelf space is like a commodity in a grocery store, right? The more Campbell's soup cans you put on the shelf, the more Campbell's soup is going to sell. Well, the grocery store is saying, what are our margins on Progresso versus Campbell's? Who's going to get the most shelf space? So to sell more, right? That is a complex issue. Which combinations of, like tomato soup sells well with bread and cheese because everybody eats cheese sandwiches, grilled cheese sandwiches, and tomato soup. Combinations, shelf space, being able to get the merchandise in on time to fill that shelf space back up. So D-Wave is betting that if we solve those problems, get those customers, and build the advanced computers later, we'll be able to do it. Other companies are saying, anybody keep up with the 2016 presidential election? Anybody surprised? That's a quantum problem. Predicting who, like, I don't want to be surprised next time, right? So can we get a quantum computer to say, what if, maybe not 2016, but if we go back to Barack Obama, one thing that Barack Obama was cool at, and I'm not saying he was ultimately cool, I'm not saying I'm not getting cool. I'm not doing, but I am saying that he used data science, right? He used data science to say, hey, I know you're gonna vote for me, but can you remind your sister who lives in Florida to vote for me? Right, she's really good at that. Right,
And
his
then
team,
will
his
there be
team.
ethical issues with the use of the phone platform?
So if you and your sister in Florida are entangled qubits voting for one party versus the other, that becomes a quantum problem. So there was a company that started analyzing election results, and they got bought out. I don't know how much they got. People are already. Yeah, it's cool. It's cool. Yeah, okay. Any other questions? Anything? I didn't follow you fascinating.
So this overview, I feel like I can think about that a little bit more. I think the analogy of 1960 programming was helpful, just really strictly because zeros and ones. So I'm curious though, for this particular problem, did you generate some results to show how this actually generated a different or better solution than the Excel problem with the hard constraints? How the variability constraints proved to be insightful?
I simplified this particular article, I simplified it down so much by saying one qubit for a chunk of $1 million. It's not, the results I got was not good with Excel. Excel actually made more sense, and I visualized myself spending the money here and there, right? So in one sense, Excel would be easier for me to explain to someone who, I was ahead of the auditor. I think I would rather take the Excel results to an auditor, right? But with enough time and enough access to PhD fund data, I think I would rather use quantum because I can bring in. I think it would be easier to work with one function algebra equation. You can actually bring in more of those factors that I skip over already, like jackpot signs and different scratch-offs versus logarithms versus keynote, and point of sale restaurants versus gas stations. It would be too many of them. But one person working with the data that I downloaded, I didn't hear that.
Yeah,
Yeah. So there are advantages. I mean, I think the Excel method is easier to explain, but I think if I'm digging this one.
Thank you for,
Yes.
if you did bring in those other variables, would you then be entangling and you have to move out of the way?
So one way that I haven't done it yet, but one way I was thinking about entangling is we could divide the county up into areas, right? Here's the city in the center, and here's the how do you want to divide it up, right? And so you could entangle, if you spend money here, you're effectively influencing here. It's one way to entangle the qubits. Another way to entangle qubits, this gets a little complex. I could use the qubits as numbers, just like a 0 is a 0, a 1 is a 1, a 1 0 equals 2, that binary, but I could do it that way. So that I'm not entangling in the sense that this is 1 is 1, right? But I am using the architecture of the machine to say this is a number. I can still try to get it. One of the examples of the way documentation has is they take the traveling with salesman problem. There's a city in Europe, there's a famous math problem, and that is, I want to cross all the bridges in the city, but do it with the shortest number of steps. Right? That's a minimization problem. And they showed how they can do entanglement using the number of steps between cities. They also have an example where there's the four-color map problem. So you want to paint all the countries in the world in different color on a map, right? And the mathematical theory is that all you need is four colors. But how do you prove that, right? So they use a little bit of entanglement to say, here's 0, 0 is red, 0, 1 is blue, and 1 is so they really don't give you entanglement. They really don't. When we move to the more advanced computers that we were talking about earlier, the ones that are still being built, that's when the entanglement is we really are. And when you do it with math, you do it with matrix algebra. When you say this one changes, that changes. When this is a 0, that's a 0. This is 1, that's yeah.
Thank you.
Yeah. So you can do it on a daily, but it's really not a daily. Which makes no sense. Any other questions? Anything else? We good? Thank you. I enjoyed it. I had fun.